Okay, great. Just one second. Okay, so I'm going to be talking about MicroBridge, which is a way to connect microcontrollers to Snap so that you can use the microcontroller to control your Snap projects. And I'm just going to dive in. If I can share my screen, let's see, share screen, yes, and kind of show you how to get started with that. So let's see, share my whole desktop. So to get started, can everyone see my screen? Somebody say something out loud if you can.
Yes.
Okay, great. So I have here a microbit, and it's plugged into my laptop using a USB cable. And so what I'm going to do is I'm going to go to MicroBlocks. Actually, let me go to. I'll show you the MicroBlocks website. We have this run button here, and that will launch MicroBlocks, just like there's a run Snap button on the Snap website. And what I'll do is I'll first connect the board. And so if I click that USB icon, I get possibly more than one. In this case, I only have one thing connected. And so I'll connect to that. This thing turns green. For those of you who've used MicroBlocks, this will be a review. So now it's connected to the board, and just to prove that it's connected, I can just click this block here, and you'll see that a LED turned on there. And if I turn this off and click that, the LED should turn off. And hello, there, turned off. So I'm only going to use MicroBlocks to load a project. So I'm going to open a project. I'm going to go to examples, the other category, and I'm going to load the Snap Bridge project. So this is a project written in MicroBlocks, and as we'll see later, you can modify it if you want. That is going to be, by default, just sending pin data and sensor data from the microbit to Snap. So once that's loaded, I can disconnect this. And it's important to disconnect so that you don't have MicroBlocks and Snap both trying to talk to the microcontroller at the same time. And now I will go to the Snap website, and I'll run Snap. And I'm going to load a project, which is my MicroBlocks bridge demo, and I'll show you where you can get that in a moment. This project basically connects to the microcontroller, does some initialization, and then it runs this loop continuously updating the state. I haven't started this now, so you'll see on the stage we have some variable watchers, but they're not changing. So I'm going to go ahead and start this, and again, I have to pick the microcontroller. Now in this case, the dialog is showing me a few other things, but I'm going to pick BBC microbit because that's what it is. And you'll see this little pop-up, momentary pop-up that says Snap Bridge, and that is a good sign. It shows that you're actually connected. And after that, it starts updating some values here. So it may be hard to read this, so I'm going to make this larger. So this is the tilt X value. If I tilt it to the left, if I tilt the microbit to the left, you'll see that it becomes like a negative number. It can go up to as much as like negative 100. And then if it's level, it's close to 0. And if I tilt it the other way, it becomes a positive number up to almost 100. So I'm going to use that. I'm going to start by using that value. I think I just want to graph it. So I have a pre-prepared little script here in the form of a PNG file that I can just drop here. So this script just basically puts the pen down. It's going to change X by 1 every time and set the Y to the tilt X. So let's go ahead and try that. So now you can see that I'm kind of graphing the value here. As I tilt this, it's changing the graph. And you can see that the performance is pretty good, right? It tracks pretty closely. The Snap MicroBlocks program is sending data about 60 times a second, or it tries to at least. It's possible that on some computers, because of slower serial connections, you might not get data quite that fast, but it's pretty fast. You'll also notice that there's a little wiggle. That's just noise in the sensor. So just sitting still, it's actually changing a little bit. Okay, so that's one thing you can do. Another program you could write, and I'm going to stop this one right now. Another program you could write is something that, I mean, now that we can sort of control the sprite with the tilt sensor, I had this idea that maybe we could make a drawing program. I am not very good with this drawing program, but this basically is going to, first of all, it's moving the sprite around. So the more I tilt it, the faster it moves in a given direction. Then I also have some code in here that is that's looking for item 12 of the digital pins and item 6 of the digital pins. Those are the buttons. So one of these buttons, this left button here, is pin number 12, and that clears the display. The other pin, if I hold it down, starts drawing a line. So I can actually use this as a little drawing tool. I'm not very good at it, as I said, so I won't try to write my name or anything fancy like that. Okay, the last thing I want to show is how you can extend the MicroBlocks program to do other things. So first I'm going to disconnect. Let's try that again. Disconnect the microcontroller. I'm not sure why, but we sometimes get errors from the USB serial thing. It's kind of low-level JavaScript stuff. Anyway, what I'm going to do here is I'm going to add a broadcast receive block, and I'm going to say smile. And when I get the message smile, what I want to do is I want to make something appear on the LED display. So I'll load the LED display library. Happens there's a block in there that is a smile, and there's also a clear display block. So I'll duplicate that block, and I'll say when I get the clear message, then I'll clear the display. So basically all that we have to do from Snap is send those messages, smile or clear, and it's going to activate those scripts. In order to get this onto the board, I have to reconnect the board, and then I just have to wait for a second until it actually has completely connected, and then I'll completely downloaded that new code. Then I'll disconnect the board, and I'll go back to Snap and reconnect. And now, in theory, if I go to the MicroBlocks category and I tell the microcontroller to smile, we should get a smile, and we did. And if I tell it to clear, oops, I don't think I spelled that right, clear, then it will clear. So that's all I had to say about this, but I think Glenn and Rachel have some other things to add, so I'm going to stop sharing my screen and turn it over to them.
John, hey, John, before you stop, can you show them where they can get it?
Oh, hang on a sec. Good point. Thank you very much for that reminder. So if we go to the MicroBlocks website and you go to the wiki, under tutorials, there's a section for Snap tutorials, and the very first one is this MicroBlocks Snap Bridge. And if you go into that, it explains the setup steps that I just mentioned, how to run the Snap program, and at the very bottom is the link to the MicroBlocks Bridge program. Remember, the MicroBlocks side is built into MicroBlocks. It's one of the example programs in the other folder, but the Snap side of it is linked here. Thank you very much.
So we're hoping to add this to the Snap library, but are we connected?
Yes.
Yep, we're hearing you.
Okay, good. Because this is going to take us back to, this is confusing me. I can't tell what I'm doing. Where's the meeting? So what we're hoping to do is add it to the Snap library, but we want to be sure that it's solid and reliable. And so we're hoping that those of you who are interested can serve as beta testers to make sure it's debugged. Now, Rachel Gibson, who is an engineering teacher at Charlottesville High School, is going to show some things that her students have done using John's program. So Rachel, we want to show your.
All right, there we go.
And have you got the document camera up?
Yep. Okay, so in this one, I am using TuneScope and the microbit plugged into a shield called the MakerBit.
Does the document camera?
Yeah, so you should be able to see it. You should be able to see it in the Make to Learn Lab video camera that's in the chat or in the video. And so when I touch the little pins,
Hold on, Rachel, let's switch.
They can't see the document camera.
Hold on, I'm going to turn off our audio and you can turn on yours and
Okay.
just talk through your computer.
all right, it's good.
So can we make our computer the main one showing so you can see what Rachel's.
It is.
There we go. Cool. So yeah, so the little pins that are connected, I have those mapped to some TuneScope blocks so that when you touch a pin, it should make a note play. Oh, I might have to turn on my audio now too. Okay. Can you hear that?
Yep.
All right, awesome. So you can map, yeah, thanks. So you can map different touch sensors to different musical notes and then have that all connected to the microbit. And then another example that we had, so gotta disconnect here, is controlling a motor. And so I pair to do the same thing at pair. Oop. Oh, I think I just did that twice. There we go. So we're also controlling a motor using the snap bridge too. So that I'm controlling the speed a little bit. Now it's going slower and you can increase. And then I can turn it off too from my little interface.
Do you have the?
Oh, yeah, I can also show that too. All right, cool. So you should be able to just unplug this. And this is another game that was made. Let's see if yeah, I'm not sure if this one.
Is it connected?
I believe so.
Doesn't look like it's connecting. Did you is the other snap still connected to the board perhaps?
Oh,
Yes, I think that's the problem.
yeah, let me quick. Oh, I wonder if it's sometimes sometimes I get.
You could just unplug the board and plug it back in again. That should reset things.
Yeah. Yep. Yeah, I'm not getting a like connected.
So
Huh.
So this is why we want to be sure to debug it.
Yeah, with hardware, there's always something.
Right.
Rachel, try closing those other two tabs, the MicroBlocks tab and the other Snap tab.
Right. But I think the more important point here is that John supports a lot of different microprocessors that are used in schools. And so once you write the program for one microcontroller like the microbit, then you can also use the same program with any other controller supported by MicroBlocks. And so MicroBlocks sort of acts as varies the complexity of getting the drivers working. So rather than just being able to work with one or two microcontrollers, you can use a whole array. And we obviously want to thank Bernat and all the other people who have helped us get this microbridge to this point, because this was truly an effort with lots of so the Snap, the helicopter game was done by one of Rachel's students, and they were delighted to be able to plug in the microcontroller and control the game. So it's a low overhead way to add microcontrollers to student projects. We think it has huge potential. John, do you want us to have the last word here? And then
sure.
answer
Well,
any questions?
I guess I would end by just mentioning another way that you can interact between Snap and MicroBlocks, and that is to at least with certain processors, you can send keyboard commands from Snap to MicroBlocks. This is from MicroBlocks to Snap. This is a feature that Bernat added. So the couple of processors that it works with are the are anything based on the Atmel SAM D21 and also anything based on the new Raspberry Pi Pico 2040 chip. But the cool thing about that, and we'll have a talk about this later in the conference, is that you can make simple, very simple arcade games that just send keyboard commands to control Snap. Or Scratch or anything else that can be controlled with a keyboard command. So it's kind of like making a makey, but being able to customize it to do anything you want. So stay tuned for that. What's the name of that talk, Glenn?
It's called the Snap Arcade.
Snap Arcade. Yep.
It's on Friday.
I think that's on Friday. Yep.
And I think we have a birds of a feather at a very early hour, East Coast time on Friday morning as well.
Yep. So thanks, everyone. If there's any questions, if we have any time left, I hope people will ask questions, and I hope somebody will let us know if we've run out of time.